Okay, we have in this problem, it says to write equations for the vertical and horizontal lines passing through the point -1, -4. So we have for this point, the x value is -1, and running through this point in terms of the vertical line, okay, using the x coordinate as the guideline. So we're going to have x is equal to -1, and -4 is the y value, and in this case we have y is equal to -4. So it's kind of like thinking like your x-intercept is x equals -1, your y-intercept would be y is equal to -4, and for what we have in checking out, and the result is correct. Okay, for what we have in this problem, okay, we have a line to pass through the point 8, -5, and that will have a slope of 5/4, and it says to write an equation in point-slope form for this line. Okay, so you had the slope m is at 5/4, and the point through which the line passes we have at 8, -5. And for the point slope setup, we have y minus y01 is equal to the slope m times the quantity of x minus x01. And for y minus y01, okay, so you have y minus -5 is equal to the slope m, whereupon we have 5/4, times the quantity of x minus 8, and just fine-tuning what we have here, so we have y plus 5 is equal to 5/4 times the quantity of x minus 8. Okay. And so taking what we have in this case, so we have y plus 5 is equal to 5/4 times the quantity of x minus 8, and we have, upon checking the result, and that is correct. For what we have in this problem, it says to write equations for the vertical and horizontal lines passing through the point -2, -4. And again, for a vertical line, this is in reference to the x value. So for the vertical, we have x equal to -2, and for the horizontal line, using -4 for referencing. So we have y is equal to -4, and checking, and the result is correct. For this problem, we have an equation that is presented in slope-intercept form, and it's asking what is the slope of a line parallel to this line. Now for this given line, the slope is going to be the x-coordinate, since this equation is already expressed in slope-intercept form. So the slope is at 6, and parallel lines will have the same slope. Okay, so that will be at 6. And for the slope of a perpendicular line, okay, you're looking at the opposite sign reciprocal of 6. So in this case, we have the slope of the perpendicular to be at -1/6, and checking, and the result is correct. Okay, for this problem, it says to consider the line 6x plus 3y is equal to 9. And we're looking at the slope of a line that will run perpendicular to this line, as well as the slope of a line that will happen to run parallel. So we have with 6x plus 3y is equal to 9. If we express this equation in terms of the slope-intercept form, so getting the y by itself, and we have upon taking 6x away from both sides, so we have that 3y is equal to -6x plus 9, and we have with division by 3, okay, so you have 3y over 3 is equal to -6x over 3 plus 9 over 3. 3y over 3 becomes y. -6x divided by 3 becomes -2x, and we have plus 3. And so for this line, okay, so we have that the slope m is equal to -2. And so for what we have in this particular case, now parallel lines will have the same slope, and so in this case, so -2 is going to be for the parallel line, and for the perpendicular, okay, in this case, you're going to have the opposite sign reciprocal of -2, so we're going to have a positive 1/2, and checking out, and the result is correct. Okay, for what we have in the problem below, it says that the scatter plot shows the theater revenue and rental revenue for each of 25 movies. Also shown is the line of best fit for the data. And it says to fill in the blanks below. Okay, and it says that for these 25 movies, as the theater revenue increases, rental revenue tends to do what? Okay, so if you notice, okay, we have a positive correlation, As the theater revenue is rising, so is the rental revenue. So we would have that this will tend to increase. And again, so you have increasing both ways. You have a positive correlation. And it says that using the line of best fit, we would predict that a movie generating a theater revenue of $40 million would generate a rental revenue of approximately how many $1 million? Okay, so for theater revenue, so we have at 40 million, and on this line here, looking at what we have for the axis, okay, so you have between 8 and 10, so you would have like around $8.5 million, and checking, and the result is correct. And we have with the scatter plots below, it says that it shows the number of years of experience X and the hourly pay rate Y for each of the cashiers in Florida, each of the 23 cashiers in Florida. And it says to use the equation of the line of best fit, Y is equal to 0.90x plus 8.10 to answer the questions below. And it says to give exact answers, not rounded approximations. Okay, so for this equation, Y is in reference to the salary, X is in reference to the number of years of experience. And we have in part A, it says that for an increase of 1 year of experience, what is the predicted increase in the hourly pay rate? Okay, so kind of look at it this way. So if someone is starting out, in other words, on day one, okay, the hourly pay rate would be $8.10. And then if they had 1 year of experience, okay, you have a 90-cent jump going to $9. And then for the second year, have $9.90. And so we have predicted this would be 0.90. And for the predicted hourly rate for a cashier who doesn't have any experience, again, so if X is 0, we have $8.10. And it's asking now, what is the predicted hourly pay rate for a cashier with 5 years of experience? Okay, so in this case, for 5 years, we have the X is equal to 5, and the hourly pay rate, okay, we have 0.90 times 5 plus $8.10. So we have 4.5 plus $8.10. So we're looking at $12.60. And applying what we have here, so we have again $12.60, and checking, and the result is correct.